Hello, welcome to Svitla Systems webinar about using Amazon Web Services for your data analytics and reporting needs. My name is Mike Sweetman, and I'm a solution architect with Svitla, focusing on cloud in general and AWS in particular. For those of you who may be unfamiliar with us, Svitla Systems is a Bay Area-based software development and testing provider with over 17 years of experience and over 1,000 completed projects. We have business and development offices in the US, Ukraine, Poland, and Mexico, and are very well connected to the software developer communities in these locations with vast recruiting networks. Our projects show a wide range of development and testing expertise, including web and e-commerce, mobile applications, Internet of Things, IoT, hardware, firmware testing and development, and big data. A common thread through many of our projects is cloud and DevOps. Central to DevOps is the concept of bringing software development and testing practices to operations and infrastructure, which cloud technologies make possible. We have worked with a wide variety of public cloud providers and cloud-native tools you can see listed here, though a majority of our experience is in AWS. Reflective of the high level of our AWS experience and knowledge, and evidenced by dozens of successful deliveries, Svitla is proud to be recognized as an AWS Select Consulting Partner. This partnership provides a number of benefits we can offer to our customers who use AWS, and this webinar is a perfect example. I'd also like to take a moment and thank our partner Tech Data for their support and assistance with today's webinar. Tech Data is a worldwide organization operating in more than 40 countries with more than 14,000 employees and over 150,000 products and services. Tech Data has been recognized on the world's most admired companies list in Fortune for 11 consecutive years and placed at number 90 on the most recent Fortune 500 list. Tech Data is also an AWS Advanced Consulting Partner and one of only 12 AWS partners with the capacity, financial muscle, and legal standing to be recognized as a distributor of AWS and enabler of distribution seller partners like Svitla. Today, I am happy to be joined by Angelica Ortega, Partner Solutions Architect for AWS Mexico. In her role, Angelica helps AWS partners like Svitla ensure that their customers are making the most of their investment in AWS through technical assistance and solution recommendations. Angelica will be discussing the concept of data lakes, which are key to extracting value from large amounts of data at scale. Later, we will hear from Mark DeMeo, Executive Vice President of Consulting for Svitla, who will share details from a case study of one of our customers where we leveraged AWS to quickly deliver an impactful and difference-making big data solution. After the case study, we will have a few minutes for Q&A. Please use the chat feature in the webinar room to submit your questions for Angelica, Mark, or myself to answer during that time. First up is Angelica with an overview of the AWS offerings in data and analytics and details on data lakes. Angelica?
Thank you, Mike. Okay, please let me know if you can see my screen. Okay, I think yes. You can see it, right? Perfect. Okay, so thank you for the introduction, Mike. As you mentioned, my name is Angelica Ortega, and the idea of my role is to enable partners in different technical levels. So there is two different roles in AWS. One is the one oriented to be more technically, and the other one is the business one. I'm the solution architect one. So I'm going to talk today about how you are using data lakes and also analytics services on AWS to take the insights in your data and why you need to do this since our point of view. Okay. So let's start by saying that maybe you have heard previously that the data is the new oil in the world. And what do we mean with that? Or what is the industry is seeing now? Mainly, we are seeing three different trends that has been happening last years, actually during the 5 to 7 this years, and those are, one is a large set of amounts of data coming from connected devices, from mobile applications, from web applications. So we have a lot of sources that we need to take care of in regards of what our clients are getting into, how they are connecting to our business, and what are they are looking for, what are they interested on. The other one is the cloud driving down the cost for storage. As some of you know, previous to have a cloud model of delivering services, we used to have the storage in our data center, and sometimes we need to comply in some regulations depending on the countries, and actually we also need to decide if we need to delete some data and throw it away because of we don't have more resources to store this one. So cloud is providing a set of infrastructure that provides a cheaper storage for this, and then also we can identify different services that we are going to take care ahead in the slides in regards of get an easier access to this storage. The other trend is about the cloud by itself. And as some of you know, cloud is a pay-as-you-go model. So technically you are using it as you need. So, and you are going to pay it also for just what you need. Usually we have like a over-provided server where we can have maybe underestimated consuming usage, and maybe we are not using this on the right way, and we are paying more than the capacity that we need. So in the delivery model that we are having with cloud, we only pay for what we use. Also the elasticity and computability that refers to if we need more compute, more storage, more memory, etc., we can adjust this based on the needs on our customers. So that is the thing that you don't need to wait maybe for your server provider to give you more storage, more compute services. So you can have it in minutes actually. So these are the three trends, sorry, that we are seeing in the market, and also oriented to our customers, how they are getting this value from the data. They are having this incoming traffic or this incoming information from different sources. So this is increasing the data that they need to analyze. And also this is being used by different people, even inside the organization or outside to take or make any decision. So the idea is to have also this information analyzed to get the most of it in terms of the different stakeholders. And I'm going to talk about in the next slide of this specific topic about the stakeholders. At this slide, I would like to ask you, since I know that we have different roles in the call, which one of these roles are you? Maybe you are an architect, maybe you are an IT director, maybe you are a VP. I mean, the data is not just centralized in the business side or in the technical side. The data is being used by a lot of different stakeholders. So the idea here is to each one of those, or each one of the different roles will have different views from this information. And maybe the IT guy will use this for, I don't know, maybe provision more capacity, and the VP is going to generate another campaign strategy. So the idea is to have the right information to the right people to make the right decisions. So thinking about the use cases, what are we using data lakes? What are we using analytics? Maybe because you are in a roadmap of modernize your data warehouse. Maybe because you have already have maybe a big data strategy and a data lake strategy. And think about big data is not just like, okay, I have a lot of amount of data and I need to generate a report. No, let's think about this in the collection process that I was mentioning. We have IoT devices, mobile, web, etc. Real-time information coming in our system. Even it could be an ERP or it could be I don't know, an existing system. So we have all this collection, and then from this we have to analyze this one. We have to clean the information. We have to process, to store the information. Maybe we have some regulations and we need to keep the information for a while. So we need also to consider that this data is not just to make decisions. Behind that, there are some other compliant reasons. There are some other information that we can take from this. And also, this is for operational information that we can use. Besides this, we need to ensure what is this use case. And before starting any strategy and starting any topic in regards of the what is the service that we are going to use, how we are going to use this, we need to take care of why this data is important to our business and to the different stakeholders that we were talking about. So thinking about a traditional data warehousing approach, what we had is that we had different sources, maybe an ERP, maybe a CRM, maybe different systems in our enterprise. So from this, we have a data warehouse. And we have some reports doing with business intelligence, and maybe this is going to be delivered just to a specific area in our company. So the idea is that usually what we had at that point was to generate data silos. So independently of the area that you were working on, you maybe don't have access to the other system, or you don't have a complete overview of all the things happening in terms of data and information in your enterprise. So the idea of the modernization of this is to generate a data lake. What is a data lake? This is a component in our architecture that gives you a single source of truth, by say something, where you can get different formats, where you can get a central catalog of information and also generate a data warehouse infrastructure here. And also what you can do from here, you can generate maybe a strategy of machine learning, of predictive information. Maybe you can generate reports. Maybe you can work on get the information needed for the stakeholders that we were talking about. So the idea is to centralize this information and also have it stored in different services. And the idea is to explode this and get the most as we can from this. Now, let's think about how the customers are moving this data. This data is maybe already in your data center, and maybe you say something, oh, I'm not going to move this data. So you cannot just evolve this data warehouse. You can also extend the data warehouse to the cloud. You can also use the storage services that we have to maybe transform this data being in the cloud, or maybe you can go with our partner Svitla to generate a POC with a sample of the information that you already have, and maybe try to get some reports that you need to, I don't know, to make some decision in the next month. So the idea also for this is to have a platform that can deliver a secure way, a durable way, an available way for your information. This is a centralized platform, thinking about Amazon Web Services, where you can find the different ways to handle your information. And why to choose AWS? I was talking about elasticity. I was talking about a bit for security. I will talk about later for some of the services, more than the analytic services. We have more like 175 services in our portfolio that you can use to secure your infrastructure, that you can use to analyze, to get real-time analytics, and also providing this deep integration with the different services and areas in your company. So thinking about the way that you can use this, you can use it in minutes, actually. I think that you will wonder what is the minimum time that takes to generate a data lake. I can tell you that from scratch, you can do this in 1 hour. Actually, I will give you one sample that was set all in 1 hour. That is really quick. Even for people that doesn't have analytics or data lakes background, it is really easy to set this. And also we have an open platform. Let's think that we are not going to reinventing the wheel. And I will give you some samples about this. And also the thing about the cost effective. Doing this on a scalable way, we can reduce the cost, because that is the model of cloud. And the idea to going by each one of these areas is, for instance, we have a service called Simple Storage Service, which is one of our most famous S3 service to store data. What we can do with this service? What we can implement here is something that we call lifecycle policies, where you can have maybe we have different tiers about maybe you can set one for the frequently accessed data. You can set another that is Glacier for the data that you are not using frequently, and you are going to pay less depending on the tier that you are using. And even if you are using the most accessed data and you have a huge amount of data, that cost is going to decrease because you are using this on a huge way. Another thing is that the data lakes can scale as much as you need. So there is not a kind of a specific limit. So if you need that information in, I don't know, in the next 3 months, 6 months, 1 year, etc., you will have that opportunity and that configuration provided with our services. So besides that, the deep integration with the different services in the rest of the portfolio also will help you to not just transform the data, visualize the data, predict with that data. Once you have transformed the data, once you clean your data, you can do more things with that information. And what about what we say that we are the most secure platform? Because of, besides this analytic offering that we have also security services. And I will just pick up a couple of these ones. For instance, WarDuty is analyzing on a preventive way your infrastructure. So what you are doing here, or what you are configuring, is that identify any threat. Maybe a threat regarding with a DDoS attack also is being captured by Shield, which actually is a shield in your infrastructure. You can have a detection 24/7 in regards of the security of what you have in your data infrastructure. So we have also identity services. What those services are doing now, the thing that those are doing is providing you the right access to the right people, as granular as you need, because of the idea from here is to give the least privilege of any one of your users. So just the right people, we have access to the right information, no more than that. And the encryption side, what about this one? We have mainly 2 different ways to encryption. One is address, when your information is not moving, is not transforming, it's just stored. The other one is in transit. You can have different ways to secure this and encrypt this information from not having plain text going in your network. Actually, also, if you take a look, these protocols are pretty secure by itself. You don't need to configure something else, and you can configure extra security. And what about the compliance and regulatory terms? We also have about 89 certifications in terms of our platform. And you have services such as AWS Artifact. Why is this service helpful for this? Because of what you have there is a kind of checklist where you can go and say, for instance, I need to meet the regulation, I don't know, just pick one. Maybe the ISO 9001, because it's for quality. If I pick this one, I can download the checklist and validate why AWS is covering. Remember that in our platform, the security is a share model. We just own the part of the keeping the services working. The data, how your application is working, is yours. So the idea here is just pick the checklist, validate what is covered by AWS, because we ensure that everything that is working in the cloud at the infrastructure level is secure and is compliant with this regulation and more from this one. And the other part is try to validate why is the part that you need to be compliant on too, depending on the application, depending on the firewall, etc. So the idea is a share model security, and we have a lot of services as you saw previously. What about our platform? Thinking about these processes, about the data movement or the collecting of the information, thinking about the setup of data lake, thinking about the analytics per se once the information has been transformed, and also the visualization. We have offering in the different areas for this, since the transformation, since the movement, since the maybe generate some dashboards. And I'm going to just set here a couple of those services. For instance, we have Snowball to move information directly to the cloud. We have Kinesis. Kinesis is a service that helps you to enable real-time data. You can stream on real time to our cloud and process it as you want, or maybe just need to put directly into S3. There is a version for that is Kinesis Data Firehouse that can help you with this. And we have another service that is Lake Formation, where you can use it directly and generate a baseline for this data lake. We have also AWS Glue, the service that can help you to, it is an ETL that can help you to modify this information, load this information, transform, as some of the ETLs are doing right now. For analytics, what do we have? We have a warehouse service that is Redshift. We have also supporting for Hadoop, for Spark, sorry. We have also supporting Python. So the idea is not, as I mentioned, not reinvent the wheel. And what do I mean for that is that we are also working with open standards. So maybe your team is already working with, I don't know, with Java, maybe they are using Python, maybe they are using MapReduce. The idea is not, okay, I'm going to AWS and I will just throw this, what I did with this data off and that's it. No, the idea is to take what you already did, improve this, put it in a platform that is scalable, that will cost you less, and also integrate with other services that maybe already have the machine learning algorithms, for instance, personalized, which provide you a predictive way from how your customers are using your platform. So the idea is that to improve, in case you are doing something already that is reusable, and also the idea is to keep the improvement in the things that you do. And in case you are starting from scratch, the idea is you have an easy set of services that you can set up quickly to get the most of your data in a short period of time. And as I was mentioning, this part of the analytics and the processing of large amount of data, what it demands is to have a higher capacity in compute, higher capacity in provision and memory, and just keeping the performance in the best shape. So the idea for this is also that we are providing different type of instances, different type of services that are just based on the needs from the customer. Actually, if you are starting with a strategy, we can also set some POCs to get an insight from what could be the result for analyze that information. I'm just going to give you a quick insight in regards of a couple of services, because we are going to look at them in the demo, in the case study. And the idea for this is, what do we have for move the data? We are not just analyzing the information, transforming, generating the data lake. No, what we are doing also is to provide you a secure way to move your data to the cloud. In case you are evolving to a data warehouse in the cloud, 100% in the cloud, what we can provide you is also appliances, gateways, the connection, so you can move this data really in a secure way. So the idea is also provide you this, and going exactly for some of other services in regards of the transformation of this data. We can use, for instance, AWS Glue. And what is the idea for Glue is to get a source, as you can see this in the slide. We can have different sources, and through Glue, what we are going to generate is a catalog. And from that catalog, we are going to make some queries, to make some transformation, to modify this information, and actually to generate jobs maybe that will help you to get this information on a cleaner way. And the idea will be also to have a way to report this, maybe in QuickSight, maybe in I don't know, maybe it could be Kibana, or maybe it could be Tableau, and tool that you already are using. Thinking about and going back a bit about the security, what are the challenges that we have when we set up a data lake? What we have here is that since the beginning, I mean, since the setup of the storage, going through the movement of the data to the presentation and visualization of the data, you need to secure each one of those points. Actually, a big data strategy is not like, okay, I'm going to move the data to the cloud, just transform this, clean this, and deliver a specific report. No, there is more behind that. You need to ensure that all the confidentiality of your information is provided. You need to ensure that also the information is traveling on a secure way. You need to enforce that every endpoint that you have is covered on a secure way. And actually, the set of services that I was mentioning, well, some of them, also we have firewalls, we have security groups, that those are services that what they are doing is just providing the right access, even if it is to a cluster, if it is to a dashboard, if it is to a, I don't know, to a certain source of data. Even until your IoT devices, we have services that cover those IoT devices. So the idea is to implement a full path where you can ensure the data from the end to end, that you are getting the data secure, that you are getting the data as you require with the integrity that you require, and also that in all this processing, you are not losing performance, you are not losing information, you are not losing any part of the information in the process. So the idea is to keep it secure and also keep the information as it needs to be in order to process this. What about other specific service that is Redshift? This is the offer that we have for data warehouse in the cloud. And just let me give you a quick of highlights from this service. This service is covering already the major of certifications such as SOC, such as PCI. Also, this is 1/10 the cost of traditional data warehouse. So this is also in a lowest cost. And actually, I will show you a use case where we can see that exactly. Let me look for this case study that is related with healthcare. What is the challenge, or what was the challenge with this client? They had a lot of this source information. They had this issue about the data silos. They had a lot of legacy applications that they were using to report the information from their patients. And they needed to build this one single source of truth. And this one source that can give them an insight from their patients, an insight for improve their service. So the idea was to enable this platform. And the way to do this was about to enable services. This was done for a partner in AWS, enabling S3, the one that we were talking about for storage. They are using also S3 Glacier for the data that has to be there and maybe unfrequently accessed, but they need to keep that information there because of compliance. Also, they were using another service that is called DMS, which is Database Migration Service. This is a service that helps you to move a database on a quicker way to cloud. So what they did also was to comply with the regulatory required and also retire about 27 applications. So they clean up their portfolio and set everything up in a data lake. What were the benefits? Actually, to have this information, to take off these legacy systems, actually with the taking off or retiring these services, these systems, sorry, they were able to improve the maintenance of their systems. And there are some other side benefits for this. Let's think about another client that we have, which is Coursera. Maybe you have heard of this. In case you haven't, this is a platform for trainings. This is an e-learning platform, actually. And the idea for this is that you have about 200, actually this is 190 universities and organizations providing training for more than 40 millions of users. And they have available in classes about 4,000 classes. So they are having a lot of traffic from all around the world. And they have also a specific way to personalize the experience of every one of us that is using the platform. About maybe you took a course in regards to, I don't know, data lakes. Maybe you took a training about storage, and maybe you are taking a training of nutrition. I don't know. Based on this selection that you have done previously, the idea here is provide you a personalized experience about what could be interesting to you further in the time. Maybe, I don't know, maybe if you are in the IT world, maybe you need to keep updating your knowledge. And there is a new training from, I don't know, this XYZ university. So this is done with Amazon personalized service. And the idea for this is also deliver services that have a kind of intelligence programmatically done that our customers can use. And actually this service is also used by Amazon.com, just a little commercial here. Okay, so we're going to cover with the Svitla team the specific case, but before going to that, I'm going to switch into a case. I was trying to make a demo here, but this is a short period of time. So what I decided was to show you a way to generate a data warehouse on an easy way. Let me just guide you through the sample. I'm not going technically deeply, just give you the idea of what of this process about transforming, etc. we are doing here. Also, you can go into this link in the big data use cases, and you can find the detailed information for this specific case. And actually, if you want, or maybe you are technical, if you want to set this up, what you can do is go to the video on YouTube that I am adding here. And there is a step-by-step process presented in one of our reInvent session. That is the reInvent session is the session at the end of the year where we as AWS present the customer case study, where we present some services, etc. This is like an AWS party. I want to think of that way. So you can go to the video and make the same work that I did here. You can replicate that. So the idea here is to have a data source. I'm not taking customer information in terms of maybe feedback or maybe I don't know, maybe a directly survey from the client. What I'm doing this exercise is just taking data sources from logs in HTTP format. HTTP format is the way that you go into a browser, and into the browser you generate a petition to maybe Coursera, maybe a web application, I don't know. That is the way that from technical side, we are taking a look at anything that you do in a website or in a browser is tracked. So this is the way that we track in the web component. So the idea is to gather these logs. I took a sample for this, and you can have this from your websites. You can have this for your mobile application. And the idea is uploading this information into a bucket in S3. Technically, this is a place where your information is located in this service that we are providing. From this, I applied some transforming in an Amazon EMR, that is a service that supports Hadoop and Spark. And from this, I moved the information to in a formatted way into another bucket that is S3. And from here, what I generated was a cluster in Redshift, just to be able to make some queries to process the data. Remember that one part of the data lakes is that once it is in a data lake, the information is in the format that it should be. It is a raw data. So you have the data there, and you need to process this, transform this in order to get the insight required. So once it is in Redshift, you are in warehouse. So the warehouse that you have here is, the idea from here is to get the queries. And actually, if you take a look at the query and you are not a technical, you are going to say something like, what is this? The idea is to get some visualization that is readable for everyone. So let me just go to the console very quickly. Just hold on, please. And I will show you the dashboard because I'm just want to show you how this information look in raw way, not just all the process that I did. So think about this. Let me zoom this a bit. Okay, if you are technical technical people, you are looking at this and you say, oh, okay, I understand what is this. If you are not technical and haven't seen any log from any source of data, what you are going to see here is, I'm not seeing anything. There's a lot of noise there. So the idea here is, okay, how the technical people can understand this and make this readable for you. The idea is, this is the source. I am getting this information from my users. And what I'm going to do here is try to, hold on. Try to transform the information, try to understand what my stakeholder wants, and maybe this report that you are looking here, this is the set of paths. Inside all of this, there are paths that are being consulted by our clients. So the idea is that, oh, which one of these sources is the most frequently reviewed by our users? Because of maybe the IT guy will see here, oh, okay, I need to improve the CPU, I need to improve the compute, I don't know, a specific detail at technical level. But the people in marketing will see something like, oh, okay, people is looking at how I'm selling robots, how I'm selling X product. And the idea will be, okay, I will implement a campaign here. I will implement, I don't know, maybe a strategy and discount, I don't know, a strategy to get more clients here. And maybe there is a new product that is not having a lot of traffic. The idea will be, okay, this launch was not very good. And what happened that? How are we going to modify that? And the idea will be to analyze this information, look for the root cause analysis, and try to set a pipeline to maybe the next launch will be another strategy and trying to get this. The other graphic that I have here is about the error codes. This is just mainly at technical level. This is an error from the HTTP protocol. But what this says about the performance. Oh, okay, sometimes my users are not able to reach the page. What I'm missing here, I'm missing money because of any time that the client is not accessing the way they want. What is happening here is that I am generating uncomforting in my client. So that will repercute in complaints in social networks, that will generate compliance. My client is not happy because they are not seeing what they are looking for. Okay, most of them are 200. This means in a readable way, this is that, okay, my sites are working fine. So maybe I need to increase because I am having per month, in another graphic, per month I am having 1,000 of users. And the idea will be, okay, let's increase this by the next month. Oh, I'm hoping to have this for the end of the year. Okay, what I'm going to do at business side to get my business improved. So this is data modulate in the way that you can get what you are looking for. And you can be any one of the stakeholders, technical, no technical, you can be the VP, you can be from different areas. And the idea for data, and what is this important, is because data means different things to different stakeholders. So I will close my presentation here and switch back to Mike just to proceed with the use case. Thank you so much, everyone. I will stay here for any question. Let me just turn the presentation off.
Thank you. So we're going to cover our use case with our client, Avalon AI. What Avalon is a company that was formed to help address the opioid addiction in the US by looking at how doctors are prescribing the amount of opioids to the different patient segments and how that is potentially triggering addiction to opioids and fueling the crisis. Next slide. So Avalon was originally formed about a year ago as a VC-funded company to go after coming up with a solution to how to address the opioid addiction problem. They came up with a unique idea of capturing the information from different hospital systems, different clinics, comparing how one doctor is prescribing over another doctor, and being able to go ahead and build dashboards and alerts to go ahead and identify where there's potential overprescribing or there's a better use case of the medications that could be prescribed. So since they were a startup, the majority of their time was spent arranging, getting funding, and building relationships with the different hospital systems. The initial prototype was basically a set of PowerPoint slides that somebody had put together with fake data. That is what they decided that they were going to launch with. So they went, they received the money, they signed their first several hospital systems, and now they had a problem that they quickly had to ramp up a true production application for the initial data delivery sets. So we were brought in at that point in time to help get them over this initial hump and get a true MVP built. One of the things that we looked at was how quickly, how much time we had, and what type of money resources we actually had to spend. What we found is we had a very constrained budget, and we also had a very constrained timeline of 8 weeks to stand up a true MVP. So looking around, we quickly looked at the skill sets that we had internally between their company and ours. We looked at what platforms we could quickly get access to that we could build a long-term scalable initiative from, and which would give us enough features that we could quickly adopt new features as we got feedback on the MVP progress. So what we wound up choosing was the AWS platform, because it was easy to get to. It solved a lot of our HIPAA certifications that we had to fill out for the different hospital systems, mainly because of the amount of security compliance that AWS puts into their platform. All I had to deal with was the encryption of raw files sent to me, and then doing the data masking and making sure that I had user security roles within the query capability tools to prevent any raw access to data. So that saved us several months of having to go through fighting legal battles with business partner agreements. The other thing is because we were going through and trying to build scorecards for doctors off this, we had to run initially a large set of hypotheses through the tool sets to go ahead and build models. So to accomplish that, we started off initially using a data lake strategy of just loading raw data and then parsing that through SageMaker using Python scripts to go ahead and get in a quick analysis of our data and what were relevant facts and what were not relevant facts. The other thing we had to do at that point in time was also write a morphine equivalency calculation. Since there are over 30 drugs that are usually prescribed that are considered opioids and some that are not considered opioids, we had to be able to put everything in a current currency, which is called the MME calculator, which allows us to set up comparable equivalencies of how much, quote, morphine is being given to the patient. That led to another set of challenges of how we were going to process data on the loading and doing the data cleansing. So when we looked at all these issues, what we did is we went initially with a quick data set, data lake approach, and then built some Python scripts and plots to go ahead and represent what we were seeing in the data so that we could figure out what characteristics, demographics we were going to need to model more in depth to build a truly meaningful scorecard. We were able to get a team together in just a couple weeks. We were able to actually complete the initial MVP, and we were able to actually speed up how fast we were generating the reports as we were able to take advantage of more and more of the features of the AWS set. Go ahead to the next slide. Overall, what our architecture looks like is we take advantage of a lot of the tool components of the AWS platform. We did this mainly because we didn't have time to do anything else. It was easier for us to, as Angelica said earlier, we didn't want to reinvent the wheel. Our value is that we understand the data, we understand what people are looking to see. Our goal was to reuse tool sets, apply our knowledge to how we're processing that data, and be able to strip out the meaningful points. So that was really the focus of the team, as opposed to writing as much Python code or other components as we could come up with. So what we do is we take data basically from CERN or Epic that hospital systems extract. They feed us a common format. We take that data, we load it into a set of files that our data scientists can use to go ahead and look for anomalies, data errors, and potentially new data facts that we may be scrubbing out with the current approach. After that, we use a couple of Python scripts running AWS Lambda to go ahead and move that data into a Postgres database. That gives us the ability to quickly query, sort of normalize the data, and make sure that we have all our relationships before we start feeding data to the models. The reason we do that is, obviously, we start feeding bad data to the models, it'll start to skew the results and the scoring. To move the information to the data marts that we actually report off of, we decided that, okay, we're going to go ahead and use the ETL tool 5-tran Matillion and use the data glue dictionary to go ahead and quickly build the transformation sets to sort of blow out our ERP model. The reason we do this is because we use the data that way to drive the drill down features on the interactive dashboards. It also gives us the ability to parse out the demographics when we run the descriptor sets through SageMaker to be able to have a better understanding of drilling down to different components. So one example is this, that was a finding when we ran the data. Most people that are under 30 do not have arthroscopic surgery. People between 30 and 50 usually have knee surgery. If you're over 50, you usually have spinal or shoulder surgery. They are all going to have different opioid bases. 80% of patients are obese at a minimum. That also changes the dosage. So what we found is, as we were running these data sets through and trying to model to see what we could compare, we were finding which demographics between procedure, sex, BMI measurement, and procedure, and whether you were inpatient or outpatient, were driving the amount of morphine you were being given. So the real value of SageMaker for us was being able to use it to generate the models and then bring those results back into the data marts. So what this allowed us to do is build a very dynamic scoring where we could compare across procedures. Traditionally, you can only look at morphine equivalencies within a specific CPT code or major procedure. We were able to build a weighted average and then score off weighted average based on all the demographic classes, and then average that together to be able to build trend lines. What that allowed us to do is to quickly identify which doctors have a higher assigned score than other doctors. The higher assigned scores then allow us to drill down into specifically which cases are going on and why that prescription was given, whether it was right or wrong. This also allowed us to build a couple of cluster analysis diagrams that we were able to use to start identifying high points, low points off the medium or the CDC recommended morphine dosage per day, to identify where there were cases that the dosage was higher on a per day basis versus lower on a per day basis, and see what the doctor was doing in that instance and why they chose that treatment behavior. This then allows the administrator to try to bring all doctors in a better line of how much morphine that they're giving out per patient. In a nutshell, we never would have been able to achieve our timelines without the AWS platform. We looked at several other platforms. There are other ideas were thrown out. We decided that one of the values of AWS was it's very heavy open source. We work in the open source world, so there wasn't a lot of retraining we had to do for resources. That was why we discarded the Microsoft solution. We also, from previous experience, had worked on the AWS platform. We've gone through certifications, security certifications with other clients. We've always been able to get through the HIPAA audits, SOC audits with the data we receive from them. So that was another huge consideration in being able to sign partnership business agreements with multiple hospital systems. In a nutshell, we've been very pleased with the AWS. The current application is getting ready to launch the next 7 hospital systems. One of the things that, again, we liked about AWS was we're on a pay-as-you-go model, so we'll scale as we start to roll out, and we're not sitting with a bunch of unused hardware waiting for business. Thank you for your time. I hope you found it enjoyable. I enjoyed talking to you about what we've been able to do at Svitla with AWS. Is that too short?
Thank you, Mark. No, that's great. That's perfect. Now we have a time for a few short questions and answers. A reminder, if you still have any questions you'd like us to address, please share them through the chat feature, Q&A feature in the platform. Okay. Angelica, what mistakes have you seen companies make when setting up data lakes, and how are they avoided?
Okay, I think one of the mistakes, not just for data lakes, but in IT, is just not focus on the right insights. As I was mentioning, you need to take care of what is the information important. As Mark was saying, this customer from healthcare has an objective, depending on how the usage of the medicine, I don't know, you need to understand the client need. And remember that one of the most important things that a partner from us, such as Svitla, is doing to you is helping you on a consultative way. We aim to be the company most customer-centric, and the idea is that to get into your need, getting what is important to you, and gain the value of the information. So this is one of the biggest challenge, to get the right information and have the right tools to make this. But this is not even technically, this is more like a definition and design of the solution. Yep.
Okay, thank you. You mentioned it could take as short as a month to set up an initial data lake from scratch. How long to start gaining insights from the data contained in a data lake?
Okay, this is a question kind of tricky, because of what you need to have is, you can set up the data lake in a period of time like 1 hour, the setup of the data lake. But you need to have a historical data, because it depends on your business. You can have, I don't know, 3 months, 6 months, 1 year, depending on the insight that you need. It is directly regarding to the time that you have gathering this data. So it will depend specifically to the customer. If I need to say one period of time, I will say at least 3 months, at least depending on the workload. But that will be the minimum of gathering data period of time.
Okay, thank you.
Yeah, on our side, we had to load 3 years of data into the data lake to be able to build the trend lines, because 3 month, 6 month windows are too short for surgical procedures to actually get a true reflection of what a doctor is prescribing or not. So and one of the things it causes a lot more data coming through that has to be scrubbed day one. And again, with the tool sets, the ETL components, and especially Glue, being able to build your data category and sort of rationalize what it is you're trying to do, understand good data sets, bad data sets, before you feed them through models is critical for these types of projects.
Yeah, sorry, I would like to add something there. And actually, when you are using machine learning, remember that you need a huge amount of data. Actually, months will be not enough to have a model trained. Yep.
Right. That makes a lot of sense. We've had customers come with, it falls into one of 3 categories. There's some that have a fantastic idea, but don't yet have the data. There's some that have a mountain of data and don't know how to use it. And there's some that have both problems. Have a great idea, and have a subset of the data they need, but still need to go out and get a lot more data. How about any particular tools, best tools to migrate data to AWS?
You can use different depending on the amount of data. We have services like a Snowball. We have services such as DataSync. And depending on what is the specific case, what I will recommend here is to make an analysis with our partner Svitla, because of depending on the amount of data and how you would like to transfer. Even for instance, if you just need to move the data, it could be DataSync or it could be a Snowball. But we need to take a look at the specific detailed petition. Yeah.
Okay. Okay, let me see what else we have. Suppose a question to Mark. What you mentioned time frame being key to choosing AWS. Was there anything else that went into that decision?
So as I mentioned earlier, it was the time frame of how fast the skill sets I was starting with on the internal team and the HIPAA compliance as I got involved with reviewing the business agreements and what language was in those agreements. So basically for each partner, healthcare partner we work with, we go through a small HIPAA audit. To quickly knock those out, there was a lot of information that I think Angelica showed earlier that you can actually just get off the AWS site. So we were able to use a lot of those templates, and then all I had to describe was the user role security and the encryption of the raw files and the masking rules. So that shortened the amount of effort I had to put in to get a boarding agreement done.
Okay, okay, great. All right, with that, I'd like to conclude today's webinar. Thank Angelica, and Mark for their presentations, and thank all of you for your time and attention. We're looking forward to hearing more about your particular challenges and how we can help you solve them using AWS. Thank you.